Okay. Advanced water treatment. So we are already familiar some unit operations with surface water treatment and groundwater treatment as well. Okay, we are also familiar with different unit operations, and there are a lot of techniques to remove specific contaminants. Okay, very specific contaminants. Okay, or if you want to remove solids, and to a considerable extent, you may also use some sort of filtration technologies. If you want to remove salt, you may also use a lot of reverse osmosis and other dialysis technologies. And if you want to remove pathogens, you also use some sort of advanced treatment technologies for removal of complete destruction of pathogens. And if you want to remove nitrate, then you may have a special technology. If you want to remove odor, you have a special technology. If you want to remove color, you have a special treatment methods. Okay, so other than what are the materials is cannot be removed other in a traditional water treatment systems, you can plan it in a advanced treatment systems or advanced treatment technologies. Okay, yeah, yes, okay. And another important feature is you can also have your systems with the minimum footprint. Okay, please make a note on. And I think you would have seen a very lengthy layout diagram to treat the surface water. Okay, starting from mixing and flocculation chamber and sedimentation tank, filtration and disinfection, which may require a larger or a bigger footprint. Okay, so imagine now and all mixing, flocculation chamber and the stabilization tank and filtration can be managed in a single systems called microfiltration units. Microfiltration units, thereby the unit operations are very, very compact. Is it okay? Now you could compare the traditional surface water treatment with advanced treatment techniques. Is it okay?
Yes, sir.
Yeah, it's very simple and very smaller footprint. I could able to manage water treatment, even the quality better than that of your normal treatment systems. Okay, so this is one example where you can plan microfiltration systems. Probably you would have heard about the word also in your households. Microfilter and ultrafiltration, nano filtration, reverse osmosis. Okay, ion exchange resin columns, and UV disinfection, ozone disinfection. So these are some of the topics of latest interest, okay, which may take care of your water or contaminant removal to a possible extent. Okay, yes. This is your ion exchange softening. This also, I guess, we have discussed in the treatment chain. It's very easy. Okay, you need not have any aeration, you need not have any contact tank, you need not have any lime softening treatment plant. You can have directly a column with ion exchange resins. Okay, resins may have sodium resins. Resins may have, okay, and whatever the water which is comes in with lot of calcium and magnesium. So calcium and magnesium will be replaced in the resin. Okay, so sodium will be replaced and calcium and magnesium will be added to the resin. So then what will happen? Obviously, treated water from the ion exchange resins may be free from calcium and magnesium, and obviously indirectly say that it is free from hardness. Okay, during the course of time, the efficiency of your ion exchange resin will come down. Then you have to regenerate. Regenerate it also is very simple. So what you do now? Then all your sodium resins or sodium will be filled with calcium and magnesium. Now you have to replace after, say example, ion exchange saturation. You add some sort of a regenerant, which will also again replace calcium and magnesium as sodium, and you can also use it for multi times. Is it okay?
Yes, sir.
Okay, this also we have discussed in the layout diagram. Ion exchange resins, very simple. Ion exchange resins are sodium resins. Okay, imagine our sodium resin, and you can allow the water with a lot of calcium and magnesium. There could be an ion exchange reaction. Sodium in the resin will be replaced as calcium magnesium, and treated water doesn't contain any calcium magnesium. So during the course of time, all your resins will be filled with only calcium magnesium ions. Now the resins can be used for multi times. You can also reuse. So reuse, now you have to clean or regenerate the say example ion exchange resin is just stop the influent and go for a regeneration. Regeneration is very simple because already these all resins are with a lot of calcium and magnesium in the resin. So I had to replace calcium and magnesium resins by adding sodium salts. Okay, so calcium and magnesium will be replaced again against sodium, and once this sodium is being saturated, then you can start with your treatment option. Is it okay? This cycle continues in the case of multiple operation and say example, regeneration. Okay, yeah. So we'll go directly with the advanced water treatment. Okay, and if you expect to have additional treatment for the removal of suspended, colloidal, and dissolved constituents after the removal of conventional treatment, please make a note on. That's very simple. Okay, so I can able to remove as per standards to extent of suspended solids and other colloidal and dissolved constituents from the water. But if you feel if you want to have further treatment, you can also have these technologies in point of use or in the household. That is something is important. Okay, so these treatment systems are also called as a tertiary treatment. Please make a note on advanced treatment, or otherwise is called as tertiary treatment. Please remember, very simple. And water is being treated to a considerable extent at a treatment plant. If you feel like if you want to remove further solids or further colloidal matter or further dissolved constituents in the water or in the supplied water, you can plan for any advanced or tertiary treatment options in point of use. Okay, yeah. So these are the pollutants to be removed. Number one, excess amount of calcium, sodium, sulfates, nitrates, and phosphates can be removed by simple techniques. And if it is anything on the highly complex organic compounds, that also can be removed by the advanced water treatment systems. Please make a note on that. Something is important. Okay. So anyway, that treated water, normally I think you would have noticed drinking water quality standards. Okay, drinking water quality standards where calcium is around 40 or 45 milligram per liter. Okay, if you feel like whatever the calcium is supplied to you, it is in excess, then you can plan for some advanced or tertiary treatment systems. If you want to remove excess sodium, if you want to remove excess potassium, if you want to remove nitrate and phosphate, you can have some advanced treatment techniques. Okay, yeah. And these are the necessity or objectives of advanced treatment systems. Number one, to remove the organic matter and the total suspended solids beyond what can be achieved by conventional treatment. Okay, so beyond conventional treatment, if you want to remove solids, you can plan. And to remove the residual suspended solids, yes, you can possibly use advanced treatment technologies. If you want to remove the nutrients, nitrate and phosphate, you can plan for. Or if you want to remove specific inorganic and organic constituents, you can plan for either advanced or tertiary treatment options. Okay, so these are the technologies available in market. Now, if you want to target the removal of organic and inorganic colloidal and suspended solids, you can go for a filtration techniques. Please make a note on. Either you can plan. Anyway, this is very common. You can also have a small scale depth filtration or surface filtration in the household, or you can simply follow some membrane filtration techniques. Membrane, based on the size of the opening, you have a membrane filtration, microfiltration, ultrafiltration, nanofiltration, and also have a reverse osmosis. Okay, so please make a note on. This is something important for the removal of organic and inorganic colloidal and suspended solids. And if you want to remove dissolved organic constituents, okay, in the dissolved form, either you can use adsorption techniques. Okay, you would have seen GAC column in your households, granulated activated carbon for the removal of dissolved organic constituents, or you can plan simply reverse osmosis, or you can use dialysis, or you can use distillation units, or you can use some sort of chemical additions, chemical precipitation, chemical oxidation, or advanced oxidation process. Okay, so use some technology where you can convert or remove all dissolved organic constituents. Okay, yeah. And if you want to remove dissolved, I guess this is inorganic. Okay, dissolved inorganic constituents, you can use ion exchange or reverse osmosis, dialysis, distillation, and chemical precipitation. Okay, please make a note on how to remove dissolved organic constituents and how to remove dissolved inorganic constituents. Okay, yeah. And these are removal of biological. If you want to remove biological constituents, you can plan for depth filtration or membrane filtration, adsorption techniques, and exchange, distillation, and also advanced disinfectant technologies. That's what I told you. You can also have ozone disinfection and UV disinfections in a small scale level at point of use technologies. Okay, in the household. Okay, yeah. So we'll discuss one by one. Number one is membrane. Probably you would have heard about membrane treatment techniques, starting from microfiltration, nanofiltration, and also ultrafiltration. It's very simple. You just should have a semi-permeable membrane that have a pore size of 3 angstrom. Please make a note on that. This is that the pore size is less than 3 angstrom, and 1 angstrom is 10 power minus 8 centimeter, 10 power minus 8 centimeter can remove the dissolved impurities in water as well as wastewater. Is it okay? You can use a semi-permeable membrane which will allow the water to pass, but it may not allow anything to re-entry. Okay, semi-permeable membrane which may have a pore size of 3 angstrom. 1 angstrom is equal to 10 power minus 8 centimeter can remove dissolved impurities in water. Okay, and the process allow the water to pass through the membrane is called as osmosis, or otherwise is called as hyperfiltration. Please make a note of this. Something is important. The process allows the water through a membrane, that is called osmosis process or hyperfiltration process. Okay, and the process in which ions and the solute that pass through a membrane is called as dialysis. Please make a note of that. Something is important. Okay, hemodialysis you would have come across. Okay, for a kidney patients, they may also use dialysis. Dialysis in this instance, you just purify your blood. That means it will remove all your ion as well as solutes. Okay, the process in which ions and solutes that pass through a membrane, that is called as dialysis, and which is also being used extensively in the medical field. Okay, please make a note on the process that allows water to pass through a membrane, that is called osmosis. The process in which ions and solutes that pass through a membrane, that is called as dialysis. Okay, and the membrane process in the theory is based on reverse osmosis concept. Osmosis, you would have come across definition of osmosis is the natural passage of water through a semi-permeable membrane from a weaker solution to a stronger solution to equalize the concentration of solutes in both sides of the membrane. Okay, so that something is important. Please make a note on that. You have a beaker or a container, and which will be separated by a semi-permeable membrane like this, and one side is this weaker solution, other side is a Bordia stronger solution. So osmosis is very simple. That is this natural passage of water through a semi-permeable membrane. This is semi-permeable membrane from a weaker solution to stronger solutions. Thereby, it will be neutralized. It will be neutralized. Okay. So this osmotic pressure is the driving force for osmosis to occur. Please make a note on osmotic pressure is the driving force for osmosis to occur. Okay, but normally in the term called reverse osmosis, you reverse this action. So what do you do now? You just apply pressure. You just apply external pressure greater than that osmotic pressure is applied to a solution. Okay, thereby the high pressure causes the water to flow against the natural direction through the membranes, thus producing higher quality of demineralized water while rejecting the passage of dissolved solids. Please make a note on that. Something is important. Please understand all the filtration theories initially started with osmosis theory. Osmosis theory is very simple. Water, okay, it is being separated. Two solutions of weaker and also stronger solutions is being separated by a semi-permeable membrane. So automatically the ions, okay, will pass from a weaker solutions to stronger solutions. Thereby equalization may happen. Okay, that driving force is called as osmotic pressure. But in the case of reverse osmosis, you just apply external pressure greater than that of the osmotic pressure is supplied to a solutions. Thereby that water and solute concentration or separation will take place. One side you may get clear water, other side maybe you have a reject. Other side you may have a reject of dissolved solids. Okay, yes, these are the driving forces of the membrane filtration process. Either you can have a pressure, or otherwise you can have an electrical potential difference, or you can have a concentration difference, or you can also make a temperature difference, or you can make it in a combination of above. Okay, if it is a pressure difference, that you can call it as membrane filtrations, and if it is anything on the electrical voltage difference, that is called as, you can say, electrodialysis or any electrical way of treatment. If it is anything on the concentration gradient, you can also simply call it as, these are osmosis process. Is it okay?
Yes, sir.
Okay, please remember what is this osmosis, what is reverse osmosis, and what are the different driving forces for the membrane process. Okay, yeah. And these membrane processes are classified as membrane microfiltration, ultrafiltration, nanofiltration, and also reverse osmosis. These words might have with, I think you would have familiar with your terms. Microfilter is very common, and ultrafilters are very common, and nanofiltration also is very common in the households right now. And reverse osmosis plant. If it is anything on driven by electric current, that is called dialysis, electrodialysis, or electrodialysis reversal. Okay, the vacuum driven process that applies microfiltration and ultrafiltration system. Okay, so what we are going to discuss: micro, ultra, nano, and reverse osmosis. Okay, that in the case of solids removal. Okay, yeah. Now you could understand better. You can have a microfilter. Okay, these blue color indicates a semi-permeable membrane which will allow the water to pass, monovalent ion to pass, multivalent ion to pass, virus allowed to pass, but it will retain bacteria. It will also retain suspended solids. If you want to, if you have objective to remove only suspended solids, then you can simply go for microfilter units. Is it okay?
Yes, sir.
Okay, ultrafilter, again it will retain all virus also. Okay, and if you want to, or if you have a very specific cases, you have a bacterial contamination or virus contamination in the water, you can plan for ultrafiltration. That's all. Okay, it will retain your virus also. Nanofiltration, it will also retain all monovalent ions, virus, and bacteria, and also suspended solids. Okay, that you can plan for nanofiltration. Please remember reverse osmosis. If you happen to visit or if you happen to see a reverse osmosis treatment system as semi-permeable membrane, which may not allow suspended solids, which may not allow bacteria, which may not allow virus, which may not allow multivalent ions and monovalent ions, it will allow only water to percolate or water to pass. Imagine now if it is everything is being removed, and you may, whatever the water, RO water you may take is only a pure deionized water or distilled water. Is it okay?
Yes, sir.
Okay, so now imagine the municipal supplies water with a good quality. They may also assure that there is no microbial contamination, but monovalent or multivalent ions are a considerable extent. Calcium might be there, magnesium might be there, sodium might be there, potassium might be there. Okay, and somebody says in your household you just buy a RO plant, that is very good treatment system. You have a RO systems in your house, and you may also buy a RO system, have it, and treat the water. Then you may have a situation. You may take water only this. Okay, only water. All other contaminants are completely been removed as 100%, and you may take only deionized water or you may take only distilled water. Is it okay?
Yes, sir.
Okay, these are simple semi-permeable retention process. That's all. Okay, these pore size are very minimum. That's what I told you, 10 power minus 8 or lower. So normal gravity filtration may not be sufficient. You have to apply with pressure difference. If you apply with pressure, external pressure, that you can call micro, ultra, and nano filtration. If you use electrical energy, that is called electrodialysis. And if you use concentration gradient difference, that is called reverse osmosis or other treatment options. Is it fine?
Yes, sir.
Yeah, this is the only difference. Microfiltration, what is the size range, and what are the different membrane materials being used in the case of micro, ultra, nano, and reverse osmosis. Just have a look. But if you use RO, it will remove everything, complete removal of contaminants from the water. Okay. So microfilter, please remember the pore size is in the range of 0.07 to 1.3 micrometer, and the typical or actual pore size is 0.45 micrometer. The particles removal range is from 0.05 to 1 micrometer can be removed. This thing. Okay. So it is very simple operation. Flow through a microporous membrane can occur without the application of pressure on the feed side of the membrane. But in most water and wastewater applications, a small difference across the membrane significant increases the flux, which is required for water production. It's very simple. Okay, this operation is like this. Okay, so water which has contaminants like microsolids and also colloids, you have a semi-permeable membrane, and it will allow the water or permeate to pass it, and it will retain all your microbial components. Okay, and now you could understand better with the microfiltration techniques. Okay, so it will remove only the colloids and bacteria, but it will allow others to pass in. Is it okay?
Yes, sir.
Yeah. So these are membrane materials. Please make a note down. They may use either polypropylene or cellulose acetate material or polysulfone. Okay, these membrane materials are polypropylene, cellulose acetate, and polysulfone. Okay, that can be constructed of ceramic and also stainless membrane. And you can also use cellulose acetate compared to other materials, but based on their durability and also the usage. Okay, and other properties. Polymers are preferred. They allow flexibility and highly favorable chemical properties. but ceramic and stainless steel membranes can be used for processes that might require higher durability. And if you happen to have situations of higher elevated pH or extreme pressure or temperature conditions or high solid applications, you can use ceramic membranes than normal cellulose acetate membranes. Okay, so these are the membrane modules you would have seen in the household also. So membrane modules, either you may have a flat sheet membranes or you may have a spiral wound membranes like this, spiral wound or tubular membranes like this. Okay, it is also been available something like a module. Okay, microfiltration membrane modules. Okay, this is the very simple microfiltration technique. It's very simple. You have a feed tank and you can have pressure because you have to apply with the pressure, thereby the water can be passed through. Okay, you can have a pressure pump as well as you can also have a considerable maintenance of the pressure, and water will be pushed through and the solids will be retained and water will be taken care and removed. The retentate, whatever it has been retained on the one portion of the membranes can be recycled back, and you may have a treated water for a simple supply. It's very small footprint. Okay, so these are different microfiltration modules you would have seen in the railway stations and commercial establishments like this. These are membrane cartridges, and comparatively to a traditional system, these are very, very small, and it will also occupy a small footprint. Okay, yeah. So I'll stop here, and probably one more class we'll see the remaining, and then we will close advanced treatment technologies. Yeah. So any clarifications here? Just have a look. These are very simple fundamental concepts. It is also been exposed to your day-to-day operations or day-to-day life. Probably in the household also you would have seen or you would have used these technologies. Okay. Have a concept definition and what is the process, how the process will work, and what is the advantages and drawbacks of each system. That is more than sufficient for the examination point of view. Okay. Yeah. Thank you.